Hello everyone and welcome back to my channel. So today we are going to discuss about Kubernetes. In the previous video, we discussed about the Docker fundamentals. So if you have not watched that previous video, I would request to all of you to please go and watch day one video where we have covered Docker fundamentals because it is the foundation of this video. Without understanding containers, it is not possible to understand Kubernetes as well. And today we are going to talk about what Kubernetes is. So it is important to go through that video. Okay. So in the previous video, we understood what Docker is and how containers work, right? How they resolve the issue created by the dependencies and how they help the application deployment across multiple environments. Okay. Now, what Kubernetes is? So basically, Kubernetes is a container orchestration platform. Now, what does this mean? Basically, it manages containers. Now, manages in what terms? It automates the deployment, scaling, as well as management of containerized applications. It provides powerful capabilities for automation, scalability, and robust management of your containers. So basically, overall, you just for now just try to understand Kubernetes is managing your containers in an automated fashion. That's all. Okay. Okay. So I hope this is clear. Now, in the next slides, we are going to understand what are the different features of Kubernetes, what are the different problems that are solved by Kubernetes so that it is useful to us. Okay. So in this video, we are going to understand auto healing, high availability, scalability, auto bin packing, deployment strategies, automatic rollout and rollback, secrets and configuration management, as well as security. So all of these are nothing but the features of Kubernetes. Kubernetes is also known as KTS. Okay. Why it is so? Because if we write Kubernetes over here, the number of characters between K as well as S is 8. So they define it as KTS. Okay. So it is also known as KTS. So these are the different features of KTS which we are going to understand. Okay. Now let's try to understand auto healing. So we already understood containers, right? What we used to do is we used to deploy the containers on a virtual machine, right? And if there is a problem in the container, then we used to assign a team to troubleshoot the issue and then restart or deploy another container, right? This is what we used to do. But there was no automated way of restarting the same container. Whereas in case of Kubernetes, we have this functionality where the pod, which is the smallest unit. So basically, I'll let you know what pod is. So pod is nothing but the smallest unit in Kubernetes. Okay. So within pod, we can run multiple containers. So mostly we keep one container within a single pod. Okay. Most probably this is what is used. So Let me erase this. So if there is a pod, okay, which is in a running state, and suddenly something happens and it goes down, Kubernetes by default tries to restart the pod, and this is what we call it as auto heal, because we don't have any external intervention or any manual intervention over here. Everything is being automated. Okay, this is one part of auto healing. Now let's try to understand the other part. Now the second thing is that if the container is attached to a replica set, or a pod is attached to a replica set. Okay, so replica set is, let's say, consider a group of containers or pods that maintain a specific number of pods. Okay, so basically a specific number of pods are being maintained with the replica set. Okay, suppose the number of replicas within it is, let's say, 2. Then it has to maintain 2 pods for it, and these 2 pods belong to the same application. Okay, let's say we have a replica set and it has got replicas which are 2. Now if one of the replicas goes down, replica set is responsible for creating a new pod, but it has to maintain the number of replicas. So over here also there is no manual intervention, and it is replacing the old pod with a new healthy instance, right? So this is what is auto healing. So the first part is restarting itself, and the second part is replacing the faulty pod with the new and healthy pod within the auto healing. I hope it's clear. Okay. Now the other thing is about high availability. So let's take another example, that is replica set. Okay. And we have exposed this replica set to a service. These terms are a bit complicated. I totally understand it. For now, let's say service is a network component through which we can access this replica set. Okay. Now this service is over here. Let's say this is my service. This is attached to a replica set. And this replica set has got 2 different, let's say, pods. Okay. Now what happens is, if there is a request coming in from the users, right? And what happens is, suddenly one of the pods goes down, and also there is some time to recreate another pod, right? Instantly it won't create, right? So there is some time lag. So in between that time, what do you think? Will the uh, will users be able to access the application, or they won't? What do you think? Let me know in the comment section. So The thing is that though this particular pod is not in a running state, and also the new pod is not completely in a running state, let's say it's in a pending state. Okay. Still, the users will be able to access the application because we have other pod which is healthy and serving the request. Okay. So in this way, they provide high availability. This is in terms of pod. Similarly, let's say if we consider nodes in the sense virtual machines. Okay. I will try to erase the existing this thing. Okay. Now, second thing is about nodes. The first example was related to pods or containers. Now, this one is related to nodes, or we can say VMs. Okay. So, basically, in case of Kubernetes, we don't work on a single node. No, we work in a cluster. Right? Cluster means group of nodes. So, similarly, if one of the node is not in a working state, still we will be able to access the application, since all the containers which are running on this particular, let's say this is our container, okay, C. So this, if there is a container running on this particular pod, okay, and this node got crashed or there is some issue with this node, this container will be rescheduled on some other node, and still the application will be accessible to the users. So in this way, it provides high availability also in terms of nodes, right? You can see it distributes the application workloads across multiple nodes within a cluster. This redundancy ensures that even if one node fails, your application remains accessible and continues to serve the request, right? And provides high availability and uninterrupted service. So many what we can say features Kubernetes provides us, right? As compared to containers. If the same thing happens in case of containers, there is no such provision of high availability in that case, right? So this is the reason we can't directly deploy our applications on containers, because they can stop anytime and there is no provision of high availability or fault tolerance or auto healing. Any such feature is not available if we simply deploy our application on container. If it is a small application and it is not a what we can say an enterprise level application, then in that case it's fine if you go for containers. But in other cases, in general, if you are working for a company, then in that case it is recommended to go for Kubernetes. Okay, because managing one or two containers is fine, but managing thousands of containers is not a good idea, right? Because you will have to give 24/7 support, which is again not possible, right? And again, it will take a lot of human support over here. So it helps in automating things. Kubernetes is really a powerful tool, right? Fine. This was all about high availability. Now let's try to understand scalability. Okay. So what does scalability mean? Let's say your pod, you have a pod running, okay? And it has the capacity of serving 20 requests per second. Okay. And the traffic coming is of like 5 users. Will it be able to satisfy? Definitely. 5 users means 5 requests. We can provide 20 requests. So I am good. The traffic increases to 10. I am good. It increases to 20. Still I am good. Now slowly it is increasing to 50. Oh my god. This is going out of my capacity. Now what to do? In this case, Kubernetes has such a feature known as horizontal pod autoscaler. What it does is, if the demand increases, it will increase the number of pods as per their capacity. Now over here, since it's 50, it will have to create 2 such pods with a capacity 20 requests per second. Right? So it will have to scale up, right? Similarly, again, it reached 50, and after that, the request decreased again to 20. Now, is there any necessity of these 2 extra pods? Because this pod alone is sufficient to fulfill the requests. Then what is the need of these other 2 pods? So Kubernetes will intelligently de- uh, destroy these pods since they won't be required. So it is managing and optimizing your resources brilliantly, right? Thus saving your costs and working only as required, right? It will spin up more containers to handle the load. If the traffic increases, it will increase the containers. But if it decreases, it will scale down to optimize the resource usage and reduce the operational costs. This is very, very important. So you can also read about horizontal pod autoscaler. Even if you don't know, we are going to cover everything in this series. Okay. So this was about scalability. Okay. Now the next topic is automatic bin packing. Okay. Now let us consider that you have a node over here. Okay. Let's say you have node 1 over here and you have a container C1 running on it. Okay. Now this container is almost completely used up. All the resources are completely utilized and it doesn't have enough resources, that is RAM or CPU. Okay, so in that case, it creates one more container. Okay, which we already discussed, right? In case of horizontal pod autoscaling. Similarly, in case of resources as well, it does the same. Okay. Now, if the node capacity, now there is a node capacity, of course, node is nothing but a virtual machine. So it also has its capacity, right? And this capacity is also full. Then what it does is it will make use of another node for allocating containers, right? So the new containers will be allocated, let's say C3 will be allocated on node 2. Okay. Now if there are no containers on the node, for example, there is one more node over here, that is node 3. Then in that case, it is flexible enough to remove this node also because there is no resource, right? So it efficiently packs the workloads. Okay, maximizing resource utilization and minimizing the wasted capacity across the infrastructure. This is what is done by the KTS. So, resource utilization. should be maximum and wasted capacities should be minimum. This is something you should remember, okay? So it intelligently schedules the containers onto available nodes and it assesses the resource requirements for of each container and the available resources on each node. I hope it's clear to you. Okay. So this is very simple concept. Okay. So just consider about the efficient usage of your resources. And this concept will be very much clear to you. Okay. Now let's move on to the next slide. So the next topic is on deployment strategies. Okay. So let us understand why do we need these deployment strategies. So basically, let us consider we have a pod running an application with version 1. There is some update in the application that the developer has made and we want to deploy it onto our production. So it is not the case that I will just delete the previous one and create the new one, because it is going to lead to downtime. Though it would be in seconds, but still it would be huge because multiple users won't be able to access your application, which might create huge losses in your business, right? Which also creates a kind of bad impression for users, right? So it is desirable to reduce the downtime. Okay. So Kubernetes has some strategies with the help of which we can reduce the downtime. Okay. So the strategies are like rolling updates, blue green deployments, we have Canary deployments as well. Okay. So what actually happens in case of rolling deployments? So basically, you can consider that suppose you have V1 version, two different or three different pods you have with this particular version V1, and we want to upgrade these applications to version 2. Then in that case, how would you do that? So in case of rolling updates, they bring down this particular pod, upgrade it to V2, keeping the rest of the pods as it is. So in short, they date the versions one by one so that the whole application won't be facing a downtime, right? So the users are still able to access this application, right? Because these are up and running. So once this V2 is up and running, it will go to another pod with V1. It will delete this and create another pod with version V2. Similarly, it is going to do for this as well. So one by one, it is going to replace the old versions with the new ones, minimizing the disruption. So there won't be much disruption. Fine. Now, the next thing is about blue-green deployment. Okay. Now, in this case, there are two identical environments. Now, how is it? Let me show you. Okay. So basically, you have a current environment, right? Which let's say is blue. Blue is our current version. Okay. Blue environment is an environment which contains applications with the current version. And green is an environment with V2 version, which is a new one. Okay. Now, currently your users are pointing to this particular environment. Okay, what is done is that you already have one environment in production which is serving the users. A new environment is created, which is the green environment, which contains the changes for version 2, and it is tested. If everything is going fine, now this is being redirected to this particular environment. This is how blue-green deployment works. What happens is the connection of the users to this particular environment is released, and the users will now be served using this particular version v2, that is green environment. Okay, I hope it's clear. Now there is Canary deployment as well. Now what happens in this case is that, let's say, now what happens in the Canary deployments is that a part of users, let's say there are 100 users, a part that is, let's say 10%, that is 10 users. 10 users will be accessing the version 2, and the remaining 90 users will be accessing version 1. Let me put it here in a clear way. So, total you have 100 users, out of which 10 users will be pointing to version 2, 90 users will be pointing to version 1. They will test. The users will be asked to test, and if everything is working fine for this particular version, slowly and gradually the percentage pointing to version v2 will be increased. Now it's 10, they will gradually make it 50, then 90, and then gradually 100. So everything will be then be pointing to version 2. So this is how Canary deployments work, where a part of users or a portion of users are being pointing to the new release for the testing before a full release. You can see rolls out new versions to a small user subset. Okay, so I hope it's clear. Now we have automatic rollout and rollback. So let's say we have this version 1 and we have rolled it out to version 2. Okay, there is some issue with version 2. Okay, then what can be done is we can roll back to version 1. This is the feature provided by Kubernetes, which is a very important feature. So Kubernetes automates the process of rolling out new versions of your applications. This ensures a consistent and predictable update process. If a new deployment encounters issues or failures, it can automatically roll back to a previously stable version, right? Ensuring rapid recovery and minimizing impact on the users and service availability. I hope it's very clear and it's very easy concept. This is rollback and this is roll out. Now, Kubernetes also provides security. It incorporates robust security features like role-based access control. So everyone should not be given access to all the features in the cluster, because it is going to create security issues. If you give the production cluster access to a fresher and he accidentally makes some changes to the code or accidentally deletes some deployment or replica set, then in that case it is going to cost a lot, right? It is going to be a very disturbing thing. So it is important to allow control to only few people who can actually work on it with desired conviction, right? So controls who can access what resources within the cluster. So DevOps engineer will have a better access to the cluster, right? The system engineer will have admin related roles associated to it, right? Similarly, there are multiple roles. Okay. So, in this way, role based access plays a vital role in security. I hope it's clear. Now, the other thing is about namespaces. So, within namespaces, we have a logical isolation for teams. For example, let's say you have a dev team, you have a QA team, right? So, they need some sort of isolation to work on, right? If you are creating hundreds of pods in order to segregate it, to have a kind of order in which we can understand how pods are working, and we can easily access, like if the developer has to access these pods, he can easily check in the dev namespace. If QA, then they can actually check inside the QA namespace. So it is nothing but a logical isolation for teams and applications, preventing unintended interactions. Okay, so this is about namespaces. Then we have network policies. Now defines, so how should a pod 1 communicate to pod 2 is defined under network policies. Okay, so how pods communicate with each other and external endpoints, enforcing network segmentation. Okay, not only with each other but also with external endpoints, right? So this is how network policies are defined. So we are going to see all of these features in depth because I can't explain everything in the introduction video, right? Because these are huge topics, there are multiple concepts involved in this. Okay, so just have a general idea, like role based access is related to the roles, like certain roles should have certain access. Namespace is nothing but a logical isolation. Network policies is a way through which we can define how a pod should communicate with another pod, or how a pod should communicate to the external endpoints. Okay, this is how it is. Okay, which lead to the protection of our applications. I hope it's clear. Now, is Kubernetes right for you? This is a most important question. So basically for smaller projects with minimal scaling needs, it is not required to use Kubernetes. Definitely don't go for Kubernetes if you have small projects, small teams. It is going to create a lot of headache to you, because though Kubernetes is very powerful, it is not the best fit for all the scenarios and for all the projects. And for small applications, like just if you have one or two containers running and you want to set up network policies, RBAC, and deployments and everything, is it going to make sense for it? Obviously not, right? So that's why in small projects, better you go for containers. Please avoid Kubernetes, because without DevOps team, it is impossible to work with Kubernetes, because Kubernetes is a complex tool. You can work with containers, you can work with Docker at least if you are a developer, but without having a DevOps team, you want to work on Kubernetes, it's near to impossible, because Kubernetes is not that simple tool. Okay, then applications with very low traffic or simple architectures just for POCs, or kind of applications receiving very less traffic just for the experimentation purpose, then you can avoid making use of Kubernetes. Go for Kubernetes in case of enterprise applications, when you have huge number of containers which you need to manage a lot. You have a dedicated DevOps team for it. then definitely you can go for K8s. Okay. So this was all about the introduction to Kubernetes. I hope it was very much easy to understand because I tried to make it so. So if you have any doubts, you can ask me in the comment section. So thank you so much. I hope this video was very much helpful to all of you. I have also added the notes in the GitHub account. Okay, you can refer it. I have added the link in the description. Okay, so yeah, that's all about it. Thank you so much and have a nice day.